All right, welcome back. I think last time we left off at unions of sets. So remember, a union is a combination of sets. It's kind of bringing two sets together. So for an example, remember, set A is 2, 4, 8, 12. Set B is 2, 6, 10, 12, 14. So if I want to union the two sets, that means take all the elements from A and all the elements of B and combine them into the same set. Now you don't have to duplicate any numbers. For instance, 2 is in both sets, but we don't have to write 2 twice. We just have to write it once to say that's an element. Okay? So you'll see all the elements of A in here, 2, 4, 8, and 12. And you see all the elements of B in there as well. The 2's in there, of course, the 6, the 10, and 12 and the 14 as well. So it just brings all the components of those two sets together. Intersections are similar, but they're a little opposite, a little different. So intersections, I'll just go ahead and show this whole thing. Oops. Intersections denoted like this. So it's kind of that horseshoe shape like that. What this is looking for is you're looking for any elements that are both in A and in B. So at an example, here's your set A, here's your set B. The intersection of A and B is the elements that both sets have in common. So both sets have a 2 and both sets have a 12. So those are the two values they have in common. So there's your intersection of sets A and B. It's just a set of elements 2 and 12. Now here's some practice. So here I've got some sets defined, set E, set C, set M. So if I want to intersect E and C, the intersection of E and C, so that's these two sets, I'm looking for any elements that they have in common. So both sets have the element CT, which I believe these are abbreviations for states. So I think that's Connecticut. So that's the only one they have in common. So the intersection is just the set CT. All right, if we want to look at EM, let's see. E is this set, M is this set. We're looking for the intersection of EM, so I'm looking for any elements that both sets have in common. I noticed right off the bat, both sets have MA for Massachusetts, I believe, and both have MD for Maryland. So that would be the set MA, MD. Now, we're looking in the third part of this, we're looking at union of E and C. So remember, a union is bringing all the elements from each set together into one. So I need all the elements of E, which are CT, MA, and MD, and all the elements of C. I have CA, CO, and CT. Now I already have CT written, so I don't have to write it again. So I just have those elements there. Okay, 5 of them. If I want to union set E and M, set E is this one, set M is this one. So the union, bringing all the elements of them together. So let's do set E first. That would be CT, MA, and MD. And all the elements from set M would be MA, which I already have, MD, which I already have, MI, and MN. The union set M and C. So the union of set M and set C, so all the elements here. I do not believe they have any in common, so we're going to write all of them. So this would be CA, CO, and CT, MA, MN, MI, and MD. And lastly, our intersection of M and C. So remember, intersection is looking for elements that they both have in common. So M and C. Now, M and C do not have any elements in common. So what we call this is the empty set, denoted like this. That brings us to our next slide. So the empty set kind of goes without saying, self-explanatory. It's a set with no elements. There are no elements in the set, therefore it's an empty set. Now, by convention, the empty set is a subset of every set. This is just not something we need to write all the time, but it's just something you need to just be aware of. Because technically, every set you can think of can have an element that is nothing. So the empty set will fit in any set. So it's a subset of any set. You can also think like this here, just by convention. These are just some general rules. If you have a set, any random set intersecting the empty set, well, you're asking for any elements they have in common, which would be none. Because if you have a set with some elements and a set with no elements, then they're not going to have any elements in common because one set is completely empty. And another thing to keep in mind is that if you have a set A and you bring it together, union it with the empty set, you're bringing all the elements of A with no extra elements, so it's still going to be the same as a set A. So these are just general rules to kind of keep in mind. But a big vocab word to keep in mind now is disjoint. So if you have two sets, they are considered disjoint if they don't have anything in common. So the intersection of set A and B, bringing two random sets together, and they don't have anything in common, that means they're disjoint. So kind of like set M and set C from the last slide. Note that, remember that was the empty set, they don't have anything in common. That means that both those sets are disjoint. There's no relation, there's no connection between them at all. They don't have anything in common. This parentheses matter. There is a typo on this. I realized when I was going over it in class that these should be U's for unions, not just intersections. So without any parentheses, intersection of A, B, and C means I'm looking for any elements that all three sets have in common. All three sets have an A in common. So that is just a plain old A. Now, the union of all three sets without any parentheses means all the elements of every set brought together. So that means all the elements of A, B, and C, which would be an A, B, C, an E, and a D as well. So every element. Again, you do not have to write the element twice if it's duplicated in other sets. So now let's focus on this parenthesis example. So we want to first focus our attention on the intersection of A and B. So the intersection of A and B, so what do sets A and B have in common? The only thing A and B have in common is the element A. So think of this as just the element A. Oh, actually A and C. They both have A and C in common. And you bring it together with union of set C, so that means you'll have the A and the C element as well as the D element from set C. Now, if you change the parentheses around and you do your attention on the B intersect or the B union C first, well, B union C would be the set A, C, D, and E. And now you intersect this set with A. So you're asking, what does this set have in common with A? And they only have A and C in common. So notice both of these examples here were very similar, except the parentheses were just in different places. So it does matter kind of where you focus your attention on what is in parentheses and what's not. Now we'll get to the universal set and complements. So a set U is said to be a universal set if all the sets being considered are subsets of U. So for example, let's call everybody in my classroom the set U. So I'm talking everybody in the classroom is one set. And I can make subsets of that classroom. I could separate the classroom into guys, a set of just guys, a set of just girls. I could say there's a subset of just the people in the front row, or the people in the back row, or the people in the middle. Right? But all those people are still in set U, which is my classroom. So set U, a universal set, is kind of like all the elements, and every other set that we're talking about is contains elements of that universal set. So notice, well, we'll get to the example in a minute, but before I do that, the complement of A, when I say complement, we're talking about A prime. So A with an apostrophe here, that's called A prime. And this means everything but A. It's the opposite of A. That's why it's called the complement. So if A is the set of all guys in my classroom, then set A prime is all the girls in my classroom. It's everybody but those people, okay? And another example, if I said A was a set of people in the front row, A prime would be everybody who is not in the front row. So A prime is just the opposite, or everybody else who's not in that subset. So let's look at our example. Let U be this. So this is all the elements right here that we're going to talk about. CA, CO, CT, IL, and IN. X, Y, and Z are subsets of U. They have elements of set U. They don't have any new elements. All these elements in these sets are also in set U. So all X, Y, and Z are all subsets of U. So U has all the elements. It's our universal set. So X prime. X is CA, CT, and IL. X prime is all the elements that are not CA, CT, and IL. So that means X prime is CO and IN. It's all the elements in our universal set that are not in our set X. Same thing with Y prime. If we look at Y prime, Y is CO, CT, and IN. Y prime is all the elements that are not that, which I made a mistake there. So that means Y prime is CA and IL. It's the elements that are in the set U that were not in the set Y. Set Z prime. So Z is CO and IN. So all the elements that are not CO and IN would be the elements CA, CT, and IL. All right, and now that we've defined all those sets, finishing the last three here, the intersection of Y and Z prime. So Y is this set. Z prime is the one we just wrote. The intersection is all the elements they have in common. So Y, CO, oh, they both have CT. So this would be CT. They don't have anything else in common. All right, I'll skip ahead because I want to save a little bit of time. But now we have the Cartesian product. Cartesian product is kind of bringing two different sets together, elements from both sets together in an ordered pair. So all the elements will be ordered pairs. Okay, and Cartesian product's denoted like this. Instead of a U or horseshoe shape, it's now an X, like a multiplication sign. But let me make this example. Let's work this example. A survey can be conducted by either mail or phone, and in one of these cities, Atlanta, Boston, or Cincinnati. So I need to choose, or I need to write down all the possible surveys in ordered pairs. So I have to choose a method, but either mail or phone, and then I need to choose a city. So there's two things to do here. I need to choose a method, and then I need to choose a city. So let's say I choose mail. I'm going to choose the mail option, and then I need to choose a city, Atlanta. So there's one survey. I'm going to mail people in Atlanta. All right, let's come up with another combination. Well, I can choose the mail option again, but I can do it in Boston. Right? So there's another survey. I can choose the mail option again, but do it in Cincinnati. So there's another option. So those are three survey possibilities. I could do mail in Atlanta, mail in Boston, mail in Cincinnati. Well, there's more, because what about the phone options, right? I can choose to do survey by phone, and I can choose to do the phone in Atlanta. I can choose to do the phone in Boston, and I can choose to do the phone in Cincinnati. So these are all 6 possibilities for how I can conduct my survey. So this is our set. Okay? That is your Cartesian product. It's bringing elements of your method set and your city set together. You're pairing each of them up with each other. So if we want to do that here, Cartesian product of A, C, so that's this set with this set. So I'm making pairs for each of them in ordered pairs. So let's use A first. A from set A can be with B from set C. A can also be with D. Right? And now I'm just pairing all of these with all of those. So now let's look at C. C can pair with B. Oops. And C can pair with D. And then your E. E can pair with B. And E can pair with D. So there's your set. There's your Cartesian product for that. B and C, you're combining these two. So you'll have B with B. B with D. Then we'll do D with B. D with D. And then E. E with B. And E with D. Now, if you have the Cartesian product of the same set twice, so just imagine if it helps you to write this out a second time. Then you're going to pair B with B. You'll pair B with D. Then you'll pair D with B. And then D with D. So it is it's weird, but I think you get the idea. Now keep in mind that the order inside the parentheses matter. X, Y would be different than Y, X, just like B, D is different than D, B. So you have to write them down twice. It's not like, when we wrote 2 only down once, because we don't want to write a duplicate. Well, we don't want to write duplicates here either, but these are not the same. So that's why we have to write them twice, because they're separate. They're different things. All right. I think I'm going to end it there, just to save a little bit of time, because this is just an example that we did in class, but it's the same as the last example pretty much, just with a football league. So I'll stop it. I'll see you guys in the next video. Okay, hope it helped. Bye-bye.